So Algebra 2, guys, we're going to be talking about the remainder and factor theorems. The first thing you're going to try to do here is we're going to do long division with polynomials. Guys, long division is fun. Long division, guys, is like the first thing you guys did when you guys did division. And dividing polynomials works the same exact way. Now, before we even get to this problem, I do have some steps that I want to give you. These steps are the exact same as if I was doing long division with just numbers. So,
to write this equation, or do you want to steps?
I want you to have steps and this equation, so I'm going to switch the page here. So, to give you guys a highlight of what the steps are, let's just go back to say, like, what's 21? And if I divide that into, well, I don't even say we don't even have to go that large. Let's go like 7. Can I divide that into 164? Okay? This will highlight it enough. If I did long division with numbers, okay? Same steps are going to apply. We'll just do this one real quick and then we'll talk about what the steps actually are. So how would I go about setting this one up? Or it's already kind of set up. How would I go about doing this problem? You guys remember long division?
I know.
First thing you need to do is you need to kind of say, hey, does 7 go into 1? No. So if it doesn't go into 1, that means that then I need to move to the second spot and say, does 7 go into 16? And how many times? 2. So you guys would be like, oh, I'm going to put it 2 above the 6, right? And when we did that, what would we do then with the 2?
It would move on.
No, it would move on to the 4. We need to take the 2 and multiply it to 7, right? You remember that? So we write the 14 underneath 16, and then we subtract. So it would be 2. 7 doesn't go into 2, so I drop the 4 down to make 24, right? Now, remember, we didn't use the 1, we went to the 6, so what did I do? I put the number above the 6. We're going to have that pretty soon with the with our polynomials. You're going to see that we're going to set things up specifically a certain way. Now, we ask ourselves, does 2 or 7 go into 24? And we'd say what?
3 times.
3 times. And 3 times 7 is 21, and you would subtract. And when you subtract, you get 3. Now remember, long division, we could keep going. We put a decimal point, we would drop zeros and keep going. We're going to have a remainder here though. What we're going to do is say, hey, you have a remainder of 3. A long time ago, we would have stopped there. It's 164 divided by 7 is 23, remainder 3. Yes? But really, there's more to it. I can actually create a mixed number here. That mixed number is 23 and 3 out of 7. You have 3 of the 7 pieces required to make another whole one. So if you took your calculator and did 164 divided by 7, you would have the same as 23 and 3/7. Okay? This remainder is the numerator that goes over the number you're dividing into. That becomes your denominator.
6.4.
This is 6.4. Sorry. We finished 6.4. So, now going back to our polynomial, do you notice that it's set up the exact same way? We have it set up. There's something in this, though, that we normally wouldn't write. And if you look inside the division bar there, I have 2x to the 4th plus 3x cubed plus 0x squared plus 5x minus 1. That 0x squared is something we normally don't write. I don't want to put plus 0 something. So normally we forget about it. But in long division, just like when we did synthetic substitution, if you remember that with our upside down L,
Yes.
and we had our coefficients in, we needed to have placeholders. You need to have placeholders for the inside polynomial, the one inside, the one you're dividing into. They need to be in standard form. So if you need to write that down, standard form and include placeholders. I'll just put that on here. So you want them to be in standard form, and you're going to want to have placeholders. That is a 0x squared. That's the placeholder. You need to have that placeholder. So, what are those steps? So steps for doing long division. So number one, actually, I'm going to back this up. All of this stuff, guys, is step number one. Well, let's say step number one is place it in standard form and make sure you have placeholders, okay? Step number two, you need to find what makes leading terms the same. Now these steps are going to be very broad, okay? Which means I'm going to write them down first, and then we'll actually do this problem on a page to make it easier. 3. Place that above appropriate column. Okay, step number 4. Multiply it through place underneath. Five, big one, subtract. 6, repeat. And 7, I'm running out of room. Actually, I'll move 7 up top. 7 is rewrite. Whoops. Rewrite answer. Very, very vague directions because I need it to work with all the different types of problems you're going to see or the different encounters. Yes, when I say 6 repeat, you're going to repeat the process until you get to the end of your columns. Once you're done with your end of your columns, you'll have a remainder. And remember, the remainder ends up being the numerator that's written over what you're dividing into. Right? So, now let's actually get into the problem. Now, step number 1 says place it in standard form and set it up, right? Placeholders and all. It's already been done for us. We talked about how we need a placeholder if something's missing. If there was an x cubed missing as well, or a constant, you would have more zeros underneath. The divider, the one you're dividing with, does not need to have placeholders. You can have anything you want missing, it's okay. Now, what we're going to do here is we are going to then ask ourselves, how can I make an x squared a 2x to the 4th? What would I have to multiply by?
2x squared.
2x squared. Now this is an x squared. So where does it go? It goes above the x squared column. We're going to keep all of our x cubes, or x to the 4ths down this column. All of our x cubes, all of our x squareds down this column, and x's and constants, okay? So all of that's going to be in their columns. So we found out what would it take to get our leading coefficients to be the same. Step number 3, I think it was, said take that and multiply it through. What is x squared times 2x cubed? 2x to the 4th? And it should be that way because we engineered it to happen. Then we keep going. What's 2x squared times a negative 2x? So now, as we multiply 2x squared times negative 2x, it becomes a negative 4x cubed. The next step said subtract. So we're going to subtract these things. What I like to do is I like to write the word subtract there so that we remember that we are subtracting, because if we don't write that, some of us forget. Now, here's the cool thing. It's a 2x to the 4th minus a 2x to the 4th. Those should cancel. We engineered this to happen so I can cancel those out. We're dividing them out. We're getting them out of there. The thing is that I got 3x cubes and I'm subtracting a negative 4 of them.
So minus 1.
No. When you subtract a negative, you are adding, yes. So it actually becomes how many of them? 7 of them.
Okay.
And what I'm going to do is just bring everything along for the
3
ride.
minus 4.
It's 3 minus 4. Because you're subtracting a negative. Remember, we're subtracting here. So when you subtract a negative, you add. Now, this is on step 6, I think it was, where it was repeat. I am going to do the exact same thing I started off with. I asked myself, I'll change colors this time, how can I make an x squared a 7x cubed? Multiply it by what? Positive 7x. I'll put it above the x's. And then I just multiply it through. Shwum. What's 7x times x squared? 7x cubed. We engineered that to happen. 7x times a negative 2x. Seven x times negative 2x. Negative 14x squared. And 7x times 2 is 14x. And what are you going to do? Subtract them. 7x cubed minus 7x cubed is?
What?
Gone. They cancel. They subtract from each other. 0 minus a negative 14. You end up with a positive 14x squared. Bless you. 5x minus 14x. Negative 9x. And bring the 1 along for the ride. Changing colors. We start again. We start again, and we have to ask ourselves, how can I make an x squared a 14x squared? Multiply it by 14. Now, notice the 14 is the constant. It's the last of our numbers that we have. So therefore, after we're done with this, anything that's left is the remainder. What's 14 times x squared? It better be 14x squared. We want that. 14 times negative 2x. Negative 28x. And 14 times 2 plus 28. Remember, we are subtracting. (14x squared minus 14x squared), they cancel. That's awesome. We want that to happen. But now we have a negative 9x minus a negative 28. Essentially, what's negative 9 plus 28?
19.
19x. It's not negative, it's positive. Because remember, you're subtracting the negative, which actually means it's positive. And what's negative 1 minus 28?
27.
No,
29.
negative 29. You owe someone $1, and you take another 28 from them. You now owe them 29. Guys, you know you're done for two reasons. You know you're done. Number one, you already have a constant all the way up here. We put 14. 14 is a constant. We're done. The other reason is, can I make an x squared into an x? You could divide, but we're not dividing, we're multiplying. So therefore, we're done. What it means, though, is I need to rewrite it. The answer is 2x squared plus 7x plus 14. That's true. Plus, what's your remainder? 19x minus 29 out of how much? The thing you're dividing by, which was x squared minus 2x plus 2.